Okay, last problems. This first one, this says, this I know it's saying to factor because it doesn't have like an equal. So since it doesn't have an equals, this just says to factor. As soon as I see it has two terms, I know that this thing is a difference of cubes. So since it is a difference of cubes, I have to find its a and b term. Well, its a term is the cube root of 8. So how you would do that if you need to do it on your calculator, let's pull up a calculator, would be to take 8 to the 1/3 power and you would get 2. Make sure you put parentheses around the 1/3 or your calculator won't be able to do it. Cube root of x to the third is just x. Cube root of -1 or of 1. We don't worry about the sign. The sign tells us which formula to use. Would be 1. If you want to go and Google the formulas, I'm not going to write them here right now, but I'm going to put it, well, maybe I will. The formula is this. So let's plug everything in. Well, a would give me 2x, b would give me -1, a squared would give me 4x squared, ba would be plus 2x, and then b squared would be plus 1. Since it says to factor, this is factored. It has something times something else. So we are done with that one. Next problem. This time, this thing has 3 terms. And again, I know it's not saying to factor because it's not saying to solve because it's not equal to 0. So all we have to do is factor this thing. Since it has 3 terms, we're just going to figure out what would multiply together to give me -4 and add together to give me 3. Those two numbers would be +4 and -1. Because it becomes to the 4th power, these things need to be squared. So x squared plus 4 and x squared minus 1. Here's what you need to look for. The last thing was 2 terms and it was difference of cubes because it was a degree 3. These things could be difference of squareds because they're degree 2 and they have 2 terms. Here's how you check. First, they have to be a difference. They can't be a plus. So this thing won't factor anymore. This thing, since it has a minus in between, will factor more. The other thing you check is you check if you can square root x, which we can. That'll give me x. Can we square root 1? Yes, that gives me 1. So this will factor down into this. This thing, because it has a plus, will stay. That thing is now factored. Next one. This says to factor and solve. It's going to look very much like the first one because it has 2 terms. So we're going to take its cube root. Cube root of x to the third is x. The cube root of 27 is 3. Then we put it into the nice fancy formula, which would be x plus 3, x squared minus 3x plus 9. Now that's said to solve, which means we need to set both sides equal to 0. This would become -3. This, we can't factor it, so we have to use the quadratic formula, which is -b, so 3, plus or minus the square root of b squared, which would be 9, minus 4 times a, which is 1, times c, which is 9. All over 2a, which is 1. Let's do some of this. So always get that first side in, so that would be 9 minus 36, which will give me negative 27. So we would have 3 plus or minus the square root of negative 27 over 2, which would be the same as 3 plus or minus. We are going to get an I, and then we just have to do the square root of negative 27. So let's do 27 square root that thing, 5.2. That would be my answer. And we could check to make sure we did it right by seeing how many answers we have, which is 1, 1, 2, 3. Done. Next one. This has 3 terms. So we want to factor it like we did with the 2 binomials. There's something that they all have in common though, so always look for this. If you look across, see how this is 2, 4, 6, you should go, oh, everything is divisible by 2. So we'll divide everything by 2. That's going to give me x to the 4th plus 2x squared minus 3. Now we do the same game we did before, x squared and x squared. What's going to multiply together to give me negative 3, but add together to give me 2, positive 3, and negative 1. This, from last time, we could simplify again further into this. This is now factored. Let's set everything equal to 0 and solve. So x squared plus 3 equals 0, x minus 1 equals 0, x plus 1 equals 0. This would be 1, this would be negative 1. This we'd have to subtract 3, get x squared equals negative 3, and then square root both sides. I don't know what the square root of 3 is, which is 1.7. And since it's a negative 3, we get an I. Let's check our answers. I have 1, 2, 3, 4, and that was a degree 4. Next question. They want us to find the degree. So if you look here, it says multiply, then classify by the degree. So we just have to FOIL, like we've done quite a few problems of. X squared times x to the 3rd is 7x to the 5th, plus 3x to the 3rd, minus x to the 2nd. Let's do the other bit. So that would be 35x to the 3rd plus 15x minus 5 . Oh, that would combine with that. So 7x to the 5th plus 38x to the 3rd minus 1x to the squared plus 15x minus 5. This would be a 5th degree polynomial. Since it has 1, 2, 3, 4, 5 terms, you could call this a 5-nomial, but normally they just would call it a 5th degree polynomial. Okay, let's talk about real and non-real zeros. This thing over here, it's degree 5. So it has 5 zeros or roots. The imaginary roots are the things we care about. Imaginary roots have to come in pairs. So the most number of pairs that fit in, let's see, like if we took 5. So let's take 5 things here. So we just got 5 different things here. Let's see the most number of pairs we could make. The most number of pairs we could make is 2. So we could have 4 imaginary numbers. If we had 4 imaginary numbers, we'd have 1 real number because these things have to become 5. Like we said, there was 5 roots, so they have to become 5. So 4 plus 1 is 5. This one, we could also have just one of those pairs, which would be 2. And then I would have 3 roots. We could have 0 of these pairs. And I would have 5 roots. Do the same game with 8. We could have 8 pairs of imaginary things, or 0 real roots. We could have 6 and 2, 4 and 4, 2 and 6, and 0 and 8. The big thing with this stuff is you want to remember that we need to add up to be this number. So you start by taking even numbers, and then what's ever left over becomes your real numbers. Let's do the very last problem. This very last problem, you're going to look at your graph to see your real root. My real root in this problem would be -2. How would I write that as a factor? Well, I'd write this factor, as x plus 2. And that would be my answer. We can use synthetic division to kind of solve that thing, which would be -1, 0 for my missing x squared, 2 and -4. And we said this is -2 because that's where my 0's at. That carries down. Times 2 times -2, so -4 if this thing will write again. And it's deciding not to. There we go, -4. That would give me -2. -2 times -2 is +4. We could see that we would get -x squared plus 2x minus 2. And that would be the remainder of my function. To find my final answer, on this thing, since it wants the remaining roots, we would have to figure out what makes this thing equal 0. So we would have to use the quadratic formula and solve. Which I'm not going to do. It's left up on the answer key. If you want to find that, it's not too hard. You do -b plus or minus the square root of b squared minus 4ac all over 2a. And it's very, very similar to the process that we did in this problem right here. So please, if you have any questions, please email me and let me know.